Hello guys, my name is Arun Tyagi and I'm starting this new series to cover a new topic. So if you are here, if you're learning algorithms, you might have learned by now that if you want to crack big companies, it's not like you just need to master dynamic programming or you just need to master, all questions of heap or greedy approach or graph trees, right? It's possible that any category of question can come to you on that particular day, and that depends on luck, right? So you have to master all of them, which is almost impossible to do. But if you try to find patterns and solve questions belongs to that pattern, you will be able to achieve mastery on almost every category, right? And questions in interviews mostly are not as difficult as competitive programming. So if you try to find the pattern and if you just give enough time that particular topic is expecting from you to give, then trust me, you will be able to crack any big interview. So I'm starting this series on focusing on graph. If you had done a lot of questions in graph, right, even with that, when you will go to a decent interview, you will realize that you are struggling choosing in algorithms, whether I should do BFS, DFS, Dijkstra, Union Find, Bellman-Ford. There are so many algorithms, right? And that too you will struggle if you know these many things. If you do not know, then God bless you, right? Even if you know, and if you haven't done it via pattern, it will be pretty challenging. Questions will always be like, new wordings. Okay. So that is what I'm trying to come to, that, let's make a kind of mental map for ourselves that whenever question is coming, I should be able to follow a pattern to solve that. Before I jump into it, I'm a big believer of, learn by doing rather than just reading theory. So what we will do is, in all the categories, we will solve questions and then we'll try to map it to that particular pattern, that these questions fall to these patterns. Hence, now if this is something like this is coming to us, we will be able to solve it via this particular algorithm. This is with the introduction. Now I will jump to the categories which we are having, which we are going to cover in this particular series. So first thing first, we have basic traversal, which we should be knowing, breadth first search and depth first search. Obviously, we are going to cover basic questions fall under this. But I'm assuming if you are here to do mastery, these should be peanuts for you, right? It should not be a big thing for you. But anyway, we are going to cover it, so that should help you. Second, I would say from where the real thing will start is shortest path problem. And this can be of different ways. The first question itself, which I listed down here, is something like rotten oranges, which is not typical, like it will be like go from this cell to destination cell, right? It is not like that, but it fall under same category where you will apply breadth first search. So basics of BFS is, which obviously we'll read in that particular video, but crux is whenever you're looking for a shortest path, mostly BFS will help you. And that is where something like this question gives a twist, right? That there can be a multiple, you can say, starting point in this particular question, not like the one source and the destination. In this also, we actually have you can say, subcategories, which I tried to list down. Like if this is an unweighted graph, which is like you have all the nodes in a graph. If I go back to here, you have all the nodes, but there's no weight, right? If that is the case, then simple BFS can do my job. If a graph is weighted, but not with negative numbers, which is something like this, then I can do Dijkstra. And Dijkstra is nothing but same BFS, copy paste, just replace your queue which you use in BFS with your priority queue, and you are done. You will be able to cover a lot of tough questions just by this simple change. After that comes things like, with negative weightage, like if here, if you go via this route, there is like -8 in place of 8, right? Then things change drastically. Then your Dijkstra will fail. And that is where algorithms like Bellman-Ford will come in picture, and we will cover it. I intentionally chose a question here which is not even giving you negative cycle, but you will realize that how I'll be able to apply this algorithm on something like this, right? Okay. Then same way, we have these other categories which we will cover with all the questions. Once you are done with this, next category of question comes with, though we call it minimum spanning tree, MST, but if you do not know when a question is coming, because question can be a very simple wording framing, like we are trying to connect all the cities, all the metro cities in India, for example, and this is a new construction which we are starting. Then just come up with a bare minimum model where all the cities are connected, but cost of building that infrastructure is least. If you do not know this particular category, if you haven't done the algorithm recently, these two algorithms, it is pretty difficult that you will be able to apply these algorithms on that question, right? But once we will do it, then you will realize, oh, okay, I know if they are talking about minimum cost to connect all the cities, that is, it means it's nothing but minimum spanning tree. So, and it was beautiful for me as well, because I have faced questions earlier when I didn't know the algorithm. I kind of knew, but I didn't read it like a pattern, right? But once I knew, it was very easy for me to do all the questions in interview. Then next is, it's very famous topic, and especially if you have given interviews in Microsoft, you will see that topology, in a twisted way, a senior engineer tries to ask, that give me a there are libraries, one library depend on another library in .NET packages or Node packages, right? How you will load all the libraries, and how you will detect if there is a cycle dependency on all the libraries. So like that, it will be a twisted wording, but ultimately, if you know what topological sorting is, if you will just read it, and this is like one of the simplest thing you will code, but questions when you will read, you will realize, oh, if I do not know this wording or algorithm upfront, it's pretty difficult to solve it into the interview. So if you are just solving random questions on LeetCode or any other platform without pattern, in interview, ultimately you will struggle. So topology, till here itself, I would say most of the companies, most of the questions at junior level, you will be able to crack. But now we are going to a little harder category, not hard in terms of coding, but only rare, I would say very in tough senior positions, you will be asked this, or to freshers also it can be asked if they are hiring for a very high package, right? Union find, again, without doing this, solving questions is useless, right? So first we will try to just get the basics of it, and obviously once we will write the code, you will see it's like pretty simple in writing. There's nothing in the code. It's just that you have to have that mental map that, okay, if I'm having a union find, and now if I'm solving something like redundant connection, if you will read this redundant connection question and you do not know union find right now, it's impossible to solve. Okay, but once you will read it, you will see, okay, this is like pretty easy for me to write, even easier than a depth first search. Okay, so this is the next category, after which basically I would say a next level of questions start coming in. So something like strongly connected component. So if you have seen a graph, maybe let me show you a graph. Yeah, let me leverage this Geeks for Geeks page. So if you see this particular graph, right? If you are at node 2 in this graph, you can go to 1 directly. You can go to 3 indirectly. Okay. Same from 3, you can go to 2 directly. You can go to 1 indirectly. If you are at 1, you can go to 2, you can go to 3, right? So in these 3 nodes, you can go to each other directly or indirectly. But if you are at 4, you cannot go to 1 or 3 or 2, right? So these 3, we will say strongly connected components, but 4 will not come in this group. Though you can go to 4 from 1, but not at 1 from 4. So so these can be like many components in a big graph where those particular nodes comes as strongly connected components. And there is variety of questions on this. And this is not easy if you haven't done those algorithms first. And that is where we will cover Tarjan's algorithm or Nkosu-Raju's algorithm. He was an American scientist in computer science field. Once you're done with these algorithms, you will realize, these are like pretty simple question to do, though this one is pretty hard if you are doing it just after doing a lot of questions on graph and without reading the algorithm first. Next category I would say is simple. For me, it was always easy at least to solve most of the questions in this category, but it is important to practice these questions because a lot of questions will come in this category. So metrics where graph is kind of implicit. Metrics is given and you are asked to do shortest path or how many paths, and likewise there can be many questions. We'll try to do some. I listed down some here which are like I won't say these are tough, right? But practicing is important because this is like implicit graph, and if you are not in practice you may struggle, and these are like very frequently asked questions. Okay, so this we will do. Now here comes a category which is heuristic A-star algorithm, we call it. It's less likely that you will face it in any regular interview, but if you are in earning in crores and then you are giving a targeted interview and still that is a data structure interview, that is also a rare situation, but still it can happen. And this is important to learn if you want to close this category, that I know most of the things under graph. A-star is nothing but same Dijkstra which we were doing. Dijkstra is our BFS with priority queue. This is still going to be BFS with priority queue, but the trick is here we will do heuristic. Here we will follow the heuristic path. By that I mean that from a source I'm going to a target, but should I take one path where I know that I'm assuming heuristically this will be a better path? What if I have that some extra information that if I go towards this path, then my target can be achievable faster? So if graph is dense, and we'll see many questions here where you will realize that doing Dijkstra is very expensive. So in real world solution, we will never apply Dijkstra, but we'll think of something like A star, right? Obviously, it will be very advanced than even the A star, but still, this is a heuristic. And in real life systems, you will always see heuristic solutions. That is where things are, controlled. And finally, this will be my last category, which I'm going to cover. I won't say this is very difficult to come in an interview, because normally interviewer do not even think about what is the underlying algorithm per se, because questions here will be very real life based. For example, what are the maximum tasks we can assign, or what is the maximum capacity we can push through a network, right? Which are like very real world problems, which you will see in this particular category. Under the hood, you have to know these algorithms, Fulkerson, right? CARP algorithm. Once you are done with these algorithms, you will see these questions are doable. Without knowing the algorithm, without practicing multiple questions with these algorithms, it will be pretty, I would say, impossible to come up with an algorithm in the question, or come up with the solution, right? This will be the last category, very important if we want to have mastery on graph. So this is what it will be. I'll attach this sheet in the description as well. I tried to create a table for myself as well, that this I'll see just before a day before interview, if I want that whatever I have learned, just to recheck my knowledge. I try to refresh every now and then. So yeah, we are going to cover all of these categories with a lot more questions than what I have mentioned here. In easier, I'll do lesser. In tough categories, I'll do more questions, so that we can master this. Thank you very much. Have a good day.